Hi there, folks. Here we're looking at operations using our rules of exponents. And it's this idea that, okay, we've got all these rules of exponents. Now, how do we apply this to a situation where we're doing multiple operations? Okay. And so the idea here is we still want to follow order of operations, but we have to be really careful as we follow order of operations because we have to apply the appropriate rules of exponents as we do each operation. And so the thing that's tricky about this for students is, as we work through this thing, we still want to follow our regular order of operations, which is our good buddy IRMDAS. Okay. We do inclusion symbol first, then exponents and roots, then multiplication and division, then addition and subtraction. But we just have to remember, like, when I get to addition and subtraction, the exponents stay the same. Okay, that's my rule for exponents. When I get to multiplication, I end up adding the exponents. When I get to division, I end up subtracting the exponents. When I get to exponents, I end up multiplying the exponents. If I do roots, I divide the exponents. So we kind of have to think about it that way. Like, I'm still following order of operations, but it just so happens when I get to the operation of multiplication, I'm doing something different with the exponents, okay? So I'm still doing inclusion symbols first, then I'm doing exponents next, then something like multiplication and division next, and then addition and subtraction, but I have to follow the rules of exponents for those individual operations, okay? And the other thing is negative exponents. Negative exponents will almost always save those for last. So take care of negative exponents last, ignore them, just treat them like negative numbers in the process of the operation, and then deal with them at the end, flipping them to the other side of the fraction bar, okay? For example, if I look at something like this guy, again, following order of operations, when I look at this thing, I basically have two operations. I have multiplication, that's what's indicated by the parentheses, and then I have an exponent. And so I still want to follow order of operations, meaning I want to do the exponent first, okay? So in this particular example, I want to do this exponent. I want to do what's right here first. It just so happens, though, when I do an exponent, my rule for exponents is I'm going to multiply them, okay? So I still do the same thing with numbers that I've always done. And so for this one, let me get rid of that stuff that's in the way. And so for this one, for the 2 that's here, I still want to do 2 raised to the third power. And when I do 2 to the third power, I get an 8, okay? And so I'm doing an exponent here. It just so happens when I raise things to a power, I multiply the exponents as my special rule. So that's going to be x to the 9th and then y to the negative 15th. Okay, so I'm doing the exponent first. It just happens to be that the rule for exponents when I do that is I multiply the exponents. Okay, now I do the multiplication next. Following order of operations, I do multiplication next. Again, numbers still work the same way numbers have always worked. 6 times 8 has always been a 48, will always be a 48. And in this case, yeah, it's a 48. And then as I do this step of multiplication, I just have to follow rules of exponents for the variables. I add the exponents. Keep in mind that this guy right here has an exponent of 1, so that's going to be an x to the 10th. And then I add the exponents, that's y to the negative 11th. All right. And then the last thing I do is take care of negative exponents. The thing that has the negative exponent, I have to flip to the other side of the fraction bar. So the 48 and the x stay where they are. The y flips to the other side of the fraction bar, and I'm done. Okay. Next one, same kind of thing. I want to do exponents before I do any multiplication. So this time I have 2 sets of exponents and I have some multiplication. I want to do the exponents first. So I'm going to raise this first guy to this 4th power. I'm going to raise this second guy to the 2nd power. Okay. So I'm going to raise this to the 4th power. 2 to the 4th power is a 16, has always been a 16. In this case is a 16. But as I do this exponent, I follow rules of exponents for the variables and I multiply the exponents. That's going to be x to the 28th. And then that's going to be y to the 24th, okay? I'll keep the parentheses to show my multiplication. Over here, I'm doing 5 to the 2nd power, has always been a 25, will always be a 25. In this case, it's 25. And now for the variables, I apply rules of exponents. I multiply the exponents. Keep in mind, there's a 1 here, so that's x to the 2nd, and then y to the negative 10th, okay? Again, I'm not doing anything with negative exponents yet. I'm going to keep following order of operations, so I do the multiplication next. And so for this one, I multiply, and 16 times 25 is a 400. Has always been a 400, will always be a 400. But as I multiply for the variables, I follow rules of exponents, which means as I'm multiplying, I'm going to add the exponents. So that's going to be x to the 30th, and then y to the 14th, okay? And this is why I deal with negative exponents last. Here, the negative exponent took care of itself. This problem is done. I don't have to do anything else with rules of exponents here, okay? And so always take care of the negative exponents last. We don't want to have to be dealing with those more than once as things change while I do operations, okay? If I look at the next one, again, I have an exponent. I also have some division. Order of operations, I'm going to do the exponent first. So I'm going to raise this piece up here to the third power. So I do 4 to the third power is a 64. And I apply rules of exponents for the variables. I multiply the exponents. That's x to the 15th, y to the negative 6th. I still have the division written here because I haven't done the division yet. And that's what that fraction bar indicates. It indicates division. So now I'm going to do the division next. 64 divided by 8 is an 8. The rule of exponents as I'm dividing is to subtract the exponents. So that's going to be x to the 18th. Be careful of the signs there. 15 minus a negative 3. And then here that's going to be y to the negative 11th, negative 6 minus 5. And now the last thing, I'm going to deal with negative exponents. So the 8 and the x to the 18th are fine. But that y to the negative 11th, I'm going to rewrite as y to the 11th, but I flip it to the denominator. Okay, so I'm following rules of I'm following order of operations, but I'm applying rules of exponents as I go. If I look at the next one, again, following order of operations means I would do the division first because it's in parentheses. See, like when you look at these previous couple examples, there's nothing that's happening inside the parentheses. So like here, there's nothing I can do inside the parentheses, so I just go right to exponents, okay? Same thing with the previous ones, all right? There's nothing to do individually inside those parentheses, which is why I moved on to the exponents. When you look at this one, I can do the operation that's inside the parentheses, okay? So inside the parentheses is division. I should do the division first, okay? I could raise everything to the third power here, but it doesn't make sense to do that if I'm following order of operations. And it's always going to be easier when I follow order of operations. So 15 divided by 5 is going to give me a 3. X to the 4th divided by x to the 6th. As I do the division, I follow rules of exponents. I'm subtracting the exponents. That's a negative 2. Now, once again, as I do the division here, I'm subtracting the exponents. Be careful, negative 4 minus a negative 9 is like negative 4 plus 9. So that's going to be a 5. And now let's move on. I've done what's in the parentheses. Now let's move on to the exponents next. 3 to the third power is a 27. I apply rules of exponents as I raise things to the third power. So I multiply the exponents. That's a negative 6. And then a y to the 15th. Okay. And then lastly, I deal with those negative exponents. The 27 is fine the way it is. The y to the 15th is fine the way it is. But the x to the negative 6th, I have to rewrite as x to the 6th in the denominator. Okay. So follow rules of exponents. Do what's in the parentheses first, then do the exponents, then do multiplication and division, and follow rules of exponents as you go. Okay. As I'm doing multiplication, I add the exponents. As I'm doing division, I subtract the exponents. As I'm raising things to a power, I multiply the exponents, okay? But follow order of operations based on the operation that's written and apply rules of exponents to that situation, okay?